So you can see the board better. I know, Babar and Romero are short girls, but still. So make this your new seat, all right? You can see better. Before you copy that question, there are some students who claim they had a couple of questions, the last couple of problems I assigned for homework. So I'm making up the problem. So can you please copy the question that I write on this board here? If I can find a marker. Okay. So write this down, please. Find the derivative. Just say example. Find the derivative of f of x equals g of sine x, okay, at x equals 5 pi over 6, or maybe 7 pi over 6, because why not? If g dash of negative 1/2 equals 7. Okay, I just made up these values. Relax, I've done the math in my head, it'll work out. Right? So the kids who had trouble with this, because they had trouble with the chain rule. And the reason I moved this is San Diego and Ms. Mendoza, come and sit here. Okay, let this be a new seat. You can see the board better. So let's do this together, please. Let's do this together. We're applying the chain rule. All right? So before I do that, can you just make a column as in sidebar? I'm writing something on the side, all right? So there are some kids who were a little confused with the chain rule. Oh, I'm so sorry. Yeah. Okay. So I'm going over the chain rule. So let's do a couple of examples. I'm going to mix them up so you say, okay, I get what's going on. So if we have f of x equals, say, ln 8x. Okay, let's do this together. So f dash of x. So what's the slope of ln monkey? 1 over monkey times 8. Is that clear? So you operate on the outside, then operate on the inside, correct? But if you look at the board, I'm speaking over the board. So when you take the derivative of that, can you see you do not change anything there? This is 1 over that. And then affect it inside. So let's do another example so you get a feel for this. Say g of x equals, say, radical 9x. So g dash of x. So let's do this together. What's the slope of radical monkey? 2 radical monkey times 9. So if you get a pattern, then now I'm discussing 2 new problems that we talked about yesterday. This is just a review so you say, oh, I understand how the chain rule works. Now these are 2 new problems, both are different. Please take them down. For example, say f of, say, cot x. So we learned cot x yesterday. Okay, write on f of cot x. We're taking the derivative. The problem is there's a huge glare. Nothing is kind of visible. Over here. Maybe I'll turn off the light. Oh, no, I think the glare is because of the camera. Is it better? No, the glare is virtually invisible. Maybe here. Miss Jung. No, it's not visible. There's too much glare. Oh, this is actually not bad. So is this FaceTiming or just recording?
This is recording.
It's just recording? Okay, this is actually very good. It's like fairly sharp, but I need an object that is this tall to hold this up.
Push the table more over there.
Push, stand there. Okay, push
Wait,
it.
hold on.
Yeah, just push.
No, hold on. You have to move this chair.
Yeah, no. Push the chair here, then you'll be fine. Okay, go on. The other but the other problem is, since it's a mirror, the words are appearing backward.
Oh yeah, no, it'll fix itself.
It'll fix itself?
Yeah.
Okay. All right. Yeah. Because it was just white There's nothing to
Because
do.
it's
Alright.
fine.
Guys, let's do this together. Shh, we're going to accelerate now. So I'm going to take the slope. So pay attention, I'm going to take the slope. Alright? Because I'm indicating and finding the slope. So first I'll do the outside, which is just f dash of cortex. I'm using the same concept. Times. Okay, we learned this yesterday. Who still remembers? What's the slope of cortex? Negative cosecant squared. Very good. That's how the chain rule works. Now I'm going to do another problem which is very different. Very different. Stay with me, please. Let this be, say, sec f dash. So as before, we'll do the outside first. So chorus, what's the slope of sec monkey? Sec monkey, tan monkey, times f dash monkey dash. So these are very different problems. These are very different problems. So yesterday on your homework, I think it was question 19 and 20. There were two of them like that, two of them like that. But you need to understand how the chain rule works. If you don't understand how it works, then you're like guessing. I don't know what's going on. I don't know what to do. So let's finish that problem. Okay, I'm going to erase this. So it says find the derivative, and we always write a left-hand side. So that's f dash of x equals. So I'm finding the derivative of g of sine x. So tell me what to write. G dash of, very good, times cos x. Now, do I know the x value to be 7506? So I'm just going to plug it in. The answer is just magically sure. That's what my hint was. Even though we didn't do it in class, I said, take the slope, use the chain rule, plug it in, the answer should show. Find what needs to be found, and the answer will show. Guys, here's calculus notation at a. So a, x equals 7506. That means I'm finding f dash of x. So I'm going to plug it in. So g dash of sine of 7506 times cos of 7506. So now, follow my advice. So what needs to be found? Sine 7506, find it. No, look down, find it. The answer is magically sure. What's 7506? Which quadrant? So 30, reference angle. Across is -1, negative radical 3, 2. So those of you wrapping it up. So what's sine of 756? Negative 1/2. What's cos of 756?
Negative
Radical 3 over 2. Now look at me. Observe the confusion amongst kids. Look at this too. Confusion. So how do I find it? No! It was given. Be alive. It was given to you. G of negative 1/2 is 7. I told you the answer magically shows up. So it's 7 times negative radical 3 over 2. Final answer?
-7.
Radical 3 over 2. Common sense, guys. Mr. Sandigo, you were okay with that problem?
I already finished it before you even started.
Okay, no, I'm talking on the homework. You were
Oh,
okay.
yeah. I knew
So,
it.
guys, you should have just checked Mr. Sandiego's work.
I sent it late though. So
Yeah, I
don't
know.
how many people
Sooner is better than later. Guys, in general, once it crosses about 9-ish, there are kids, I'm just letting you know, because I get a lot of feedback. Kids move on to other assignments, so they're not likely to go back and go to check my math work. So it's sooner in general. If you send the homework before 8, it's convenient. After 9, kids are doing other stuff. Alright. Now let's do today's lesson. Alright. Today's lesson is on weird derivatives. Alright. There's a typo here. Ms. Dawn, if you will be kind enough to maybe text me or remind me somehow, I will send Ms. Jung this classwork. So she will actually have the problems. So the first one is actually v of t equals -16 e to the power -2 over t. Is that clear? The letter is t. But if you observe the instruction, it says using several notations. So I'm doing a notation this thing. Alright? And Miss Wynn, I would be deeply appreciative if you send these notes. Okay? So Mr. Jung, thank her. She's going to send me notes.
Wait, what? Wait, you said Mr. John.
I said Mr. Jin.
Oh.
I said Miss Wynn. Miss Wynn has promised to send notes from now on. And then yesterday, Miss Katina also sent notes. Okay, she's not very neat. Okay, guys, look at the board, please. I'm just showing you notation. Look at the board, please. Shh. Here are multiple notations for derivatives. Right now, derivatives can be written in different ways. We are familiar with two of them. Now I'm showing you the third. So if y equals f of x, this is just notation. Now, for those of you unaware of the history of mathematics, especially the history of derivatives, history of calculus, can you get the book, please? Calculus was invented simultaneously. They were contemporaries. The British mathematician Newton, who did you not know, Newton invented calculus, derivatives, and also at the same time by a French mathematician Leibniz. So they had different notations for derivatives. So one of them did y dash, or same thing as f dash of x. Exactly. We are comfortable with that notation. But today you're learning something new. Remember we write for slope delta y or delta x? But when you take derivatives, it's like differential of y, so you're learning something new. It's like dy over dx, as in delta, change in y over change in x when you take the limit. So the y variable goes on top, the x variable goes on the bottom. So observe the pattern, All of them mean the same, So one was used by Leibniz, the other was used by Newton, but textbooks allowed both of them. Alright? Now let's go to that problem. So today you'll get a few problems where it's not in terms of x and y, but there are word problems. Ms. Rios and Ms. Marzuk will tell you, you get word problems with different functions, and that's okay. So the question says find the derivative. So I'm showing you notations that we just learned. So instead of b of t, when I'm taking the derivative, does that become b dash of t then? Like f dash of x? Do you see the notation? Now I'm going to show you the other notation. Is that the same as dv, the y variable, over dt? So today you'll use both notations. So it says clearly using several notations. Okay, now let's do the derivative. Slow down. I'm warning you, these are tricky questions. Okay, so slow down, be a little humble, alright? Let me guide you. Will the negative 16 just drop down? Okay. Keep looking down, I'm going to walk you through it. What's the slope of E monkey? E monkey. Times, now I have to use chain rule. I have to find the derivative of the monkey. If you look carefully, is negative 2 a constant? Will that get pulled out now? Because I'm finding the derivative of the monkey. And also, if you're alert, is that function not like 1 over t? Okay, chorus. Take 1 over x. So what's the slope of 1 over t? Negative 1 over t squared. That is your final answer using the chain rule. It looks weird, but that's how we do it. Okay, now I'm going to combine them. What's negative 16 times negative 2 times negative 1? Positive or negative? Negative 32 over t squared. I'm rewriting this so it looks nice and neat. And then e to the power of negative 2 over t. In a multiple choice exam, that will be the choice. We all combined, rewritten neatly, nicely. It looks weird, but I'm deliberately sharing with you kind of weird looking problems. But follow the regular rules, you'll be fine. Okay, copy down B, please. We're still in problem 1. Copy down B. I'm going to accelerate a little bit, alright? Mr. Jim, you want to come in the front? You can see better, focus better, you'll be with the class. You, part of it being back and trying to copy down, that puts you behind. Mr. Torres, you can sit next to Mr. Villaforte or come closer or grab a chair, do whatever you want. Be comfortable, whatever you do. Okay, we're doing part B, please. That's B. So stay with me. Somebody tell me one notation. We're finding the derivative. A dash of t. If you got the hang of the pattern, what's the other notation? Over. Very good. The y variable is on top, the x variable is on the bottom. Okay, now let's do this together. I'm going to walk you through it, so please look down. What's the slope of cos monkey? Negative sine monkey. Times, now I'm going to apply the chain rule. If you look very carefully, isn't the constant 3 pi over 2? Are you able to grasp that? There's a constant coefficient of 3 pi over 2. So 3 pi over 2 will come outside. And then if you observe carefully, that's in the denominator. And see the denominator rule kicks in. These are actually like 1/2. Correct? Will I use the denominator power rule? So what am I writing on top? Negative 1/2. Very good. And then t to the power of 3 over 2. Yeah? Now I'm going to clean this up a bit. Right? Let's do the easy stuff first. What's negative times negative? Because that guy becomes positive. Slow down. What's 2 times 1/2? 1. Or could I cancel that guy and that guy? But the 2 times 1 half is easy because that looks weird, right? So 2 times 1 half is just 1. So now ready to clean it up. So which is the only number on top? Very good, 3 pi. And then I have sine 3 pi over 2 radical t. What 2 things will go on the bottom? The 2 and the t 3 halves. That's how we clean that up. Slow and steady, slow and steady. So each problem you can take about 2 minutes. Don't be in a rush. Again, these 2 guys were the only leftovers. 2 times 1 half was 1. 3 pi in the front. The 2 t 3 halves. No rush. Okay? Copy down C, please. And copy down D, please. Together. Copy down C and D together. Leave just one line between them. Repeat. We just need one line. Okay. For the careless kids are thinking they're the same problems. Are they? Are they these same problems? Because in C, the variable is R, but in D, the variable is H. Everybody okay there? They're 2 different variables. Alright? So we'll use, for this problem, we'll use the old concept, I'm speaking over the board, that if that is the variable, everything else is a constant. Keep that in mind for this problem. Is that clear? So, in other words, this is the variable. Is that clear? Everything else is a constant. Okay, let's do this together. Give me one notation. Thank you. S dash is R. Give me another notation. S over VR. That's correct. Now, let me repeat myself. Anything other than the variable is a constant. So what can I pull out and write? 4 pi H. Very good. Times, now it's very easy. What's the slope of R squared?
2R.
2R. There you go. Rewrite it. Final answer, 8 pi H R. Not too bad, not too bad. Okay. Okay, do D by yourself for practice. It's an easier problem, so I'm assigning the easier problem for you. Do D by yourselves. Anything not part of the variable is a constant. So these kind of problems. Do not look up. Do not look up. Those of you finished, what was the final answer? 4 pi R squared. That's it, right? Because the slope of H is 1. So it was just a trick question. Okay, easy problem. Alright. Now, the reason Rios and Ms. Marshall did not see this problem last year was that was AB. Now, that is what is called a logistic function. That's part of BC. We'll find the derivative of that function. So, copy that crazy looking function now. That one, POT. Okay, there's a very bright kid in the other class. He keeps a very low profile. In other words, he's very intelligent, but he doesn't show off his intelligence. I like that. He's called Joseph Purcell. Alright? I think so. I don't really remember first names, but I think it's Joseph Purcell. Is it?
Yeah.
Kind of? Yeah. Alright. So he answered this question. You could, if you wanted to, waste your life and apply the quotient rule. You could. But then I asked, we could apply the quotient rule. It will give you the right answer, don't get me wrong. But my question to him or to the class was, why is quotient rule a bloody waste of your time? As in, the quotient rule really doesn't apply here. You don't really need to use the quotient rule. My question was, why? Nobody speaks. Think about it, and then raise your hand. Raise your hand when you think of it. Anyone? Yes, Mr. Vidi.
You're only dealing with one variable, right? Because usually when we use quotient rules,
I know what you mean. The class does not know what you mean. Because your explanation, the communication is weak. You want to strengthen your reasoning or your expression. Express yourself better so we understand what you're talking about. I understood perfectly what you're trying to say. So say something else. You said we have only one variable. I know what you mean, but the class is one variable. Yeah, but it's always X. That's one variable. Explain better what you're trying to say.
like, there's a constant on the top.
Okay.
So
But usually in the quotient rule, I'm helping you. But in the quotient
you
rule,
deal with the coefficient on top. Right? Or there's like
Okay, can you explain, can you rephrase what he's trying to say?
There's a variable.
Thank you. In the quotient rule, there's a variable on top also.
Wait, isn't
So
that,
as,
isn't
huh?
that kind of like what I said?
Is that what he said?
Okay, yeah, never mind. I said, yeah.
Okay. So, I mean, I understood what you're trying to say. Your intent was clear, but your expression wasn't strong enough. So, here's what the quotient rule works, right? Don't write, just watch. Maybe like that. Now you know it's quotient rule. So, we don't have to use the quotient rule. Don't get me wrong. You can waste your time to use the quotient rule. Your answer will show up to be the same. But if you look at it, is it basically a constant on top? And if you think about it, isn't it like times 1 over monkey? Ah, so we use that concept. Very similar to what I was talking about 2 days ago. So can I, is that dp or dt? Okay. So can I cleverly pull out the 1200? Is that clear? I'm going to walk you through it. Look down. Isn't that actually like 1 over monkey? So what's the slope of 1 over monkey? Negative 1 over 49 plus 2e to the power of negative t over 3 squared times, now we find the slope of the monkey. I'll walk you through it. Look down. What's the slope of 49? 0. 2. What's the slope? Let me do the talking. What's the slope of e monkey? E monkey times chain rule. Thank you. Careful. What's the slope of e? No, sorry. What's the slope of negative t over 3? It's a line. I just need the slope. Very good. Negative 1 third. For those of you who are not apparent, write it down. There's a 1 there. So the slope of the line is negative 1 third. Now I'm going to clean this up a bit. Alright? There's a negative here, there's a negative here. So it'll turn positive. Is that clear? What's 1200 times 2? Keep looking down so you understand what I'm trying to tell you. 2400 divided by 3? 800. Ah, so that's the number on top. What's the other thing on the top? Look down. E negative t over 3. Very good. And what's the only thing on the bottom? 49 plus. So not too bad. Not too bad. Slow and steady chain rule. Slow and steady chain rule. Square, correct? So it looked crazy hard, but actually works out very fast. If your concepts are clear, hey, wait a second. That's actually 1 over monkey. You could waste your time. Ms. Mendoza, it's like the problem you showed me 2 days ago. You were applying chain rule and I said, what's the slope of 10? You said 0. Okay, that whole term collapsed. You remember that? The top left just collapsed. Okay, copy down the next problem. Is that what? E? What are we calling that? Is that F? Okay. Oh, the screen kind of, I think your screensaver just died or it kicked in. Or unless the battery died.
I think I might still be recording.
It will? You think so?
Can I check real quick?
Yeah, go ahead. Because the screen is black. I just went to check if everything is working fine. Okay, copy on F, please. Alright. So let me tell you, so this lesson, in case you're wondering what's going on in today's short lesson, but the actual lesson is down below, is this. I'm basically discussing weird derivatives. That is, there's a more elegant way to solve the problem. So here's an inelegant way to solve the problem. The answer will work out, but it's inelegant, which is the quotient rule. Some clever fellow tell me the easier, better, faster way to do the problem. I'll be honest with you, no one in the other class figured it out. Mr. Sidon had an idea that was somewhat useful, but it would have still taken several steps. But my method was the fastest. So I want you to make a guess, speculate. Again, the regular way is the quotient rule, but it requires you to do lots of algebra. Simplifying the radical, there's lots of work. Something even faster than the quotient rule, and neater, very elegant, like 2 steps. Anyone? There's some algebra to be done before we can take the derivative. So my speculate, I'm asking you to speculate, oh, if you do this, maybe. Okay, let me tell you how this works. Girls, if you're writing good notes, make a note. So if you have multiple numerators but one denominator, it works. We're basically using this rule. I'm almost certain I went over this in pre-calc. If you have A plus B plus C or minus, it doesn't matter, over D, you can break up the top. A over D plus or minus, B over D plus or minus C over D. Okay? I'm going to split up the top. And then take the derivative. And Ms. Marzu can you remember vaguely, that's what we do when we have to find the integral. We split it up and integrate quickly. The concept works on derivatives too. So observe please. So I'm going to write 3x squared over, because I'm breaking it up and I want to save a step. Can I write x1 half plus, what's 4 over 2? 2, because I'm breaking up the second guy, alright? 2x over x1 half. Everybody okay there so far? I'm just splitting at the top. Algebra allows me to do that. That's an algebra thing. Ooh! When I divide, what do I do with the powers? Subtract. Use a fraction trick, tell me what you get. Okay, go on. Louder. What's 2 minus 1 half? 3 over 2. There's some fool saying 1 half. That's 1 minus 1 half is 1. 2 minus 1 half here. 3 halves. And then let's do the same thing here. What's 1 minus 1 half? 1 half. Now we can easily find the derivative of that expression just using the regular power rule. Okay, now look down please. I'm going to walk you through it. So y dash, left hand side and the left hand side. Should I use the power rule? So what will the number outside become? Where's negative? Who's the fool saying negative? We're just using the power rule. I'm just using the power rule. 3 halves and 3 halves. Is everybody okay then? Just using the power rule. So 9 over 4. Careful. I'm subtracting 1. I'm the top. I'm subtracting 1. X to the power of 1 half. There you go. You observe how elegant this is? No quotient rule. It's very fast. Alright. Use the power rule again. Plus just x goes 1. Yes. X to the power of negative 1 half. Oh, but there's a 2 in, oh no, the 2 vanished, sorry. Rewriting it, 9/4 x over 1 half plus 1 over x over 1 half. Ta-da, stop. No crazy quotient rule, LCM, simplifying, multiplying the rest of them, none of that crap. So observe, girls, I hope you made a mental note. If you have multiple numerators, one denominator, split up the top. It's much, much faster. Last example. Okay, the insanely smart fellow in the other class called Abel Soto. He told me the most elegant way to solve the problem. So you guys mimic him. Who can tell me the fastest way to solve that problem? It's absurdly easy. So all I'm asking you to do is maybe rewrite, do this, do that, and it becomes a much easier problem. So who can tell me what to do? Yes, Mr. Lynch. So, like that. Okay, don't write. We're still speculating. Like that.
Yeah.
And then do what?
The twos. That's the twos.
How do the 2's cancel? Silly boy. That's not a square, you know. That's the actual number 2. There is no square that they cancel. Are you following what I'm talking about? I don't have a square that the 2 and a 1 half cancel. Anyone else who wants to speculate? Maybe do this. Yes, Mr. Lee.
You just multiply radical r over radical r.
You mean rationalize?
Yeah.
No.
So the
Okay. All right. This makes me chuckle because actually, without you realizing it, you're making it more complicated. Watch. If you have radical r and you say multiply top and bottom of radical r, Mr. Javedi, this is what you'll end up with. Radical r over r. Okay? That's even more complicated than just radical r on the bottom. Anyone? Yes. Oh, okay. Help me. He says find a derivative directly. Help me.
Like 1 over 2 rad.
Oh, I see what he's saying. Okay. I'll be honest with you. I did not consider that approach. He says, isn't that radical monkey? Okay, now, okay. That will work, but here's the thing. Watch this, please. So you have 1 over 2 radical monkey. You see, that's the logic. Let's be honest. Do you really think most of the class will get it right? This is a radical. How many of you understand what I'm saying? That's very complicated. And then times the derivative of the monkey. 3/4 of the class will make a mistake. Okay, anyone else? You have to beat Abel Soto. Because when I tell you how to do it, it's like so easy. Anyone? Any ideas? Mr. Psychosi. Okay, get ready to kick yourselves.
Oh my god.
I'll just rewrite it.
That's ridiculous.
Radical 2. For those of you who say, oh, I don't know what you did. I skipped the step. Is that radical 2 over radical r? That's a constant. I pull it out. Radical r close to r becomes negative 1. Much easier than it looks. Now let's find the derivative. Alright? What notation do I use? On the left hand side. N dash of r. Make sure you're at the left hand side. Or dn over dr. Everybody okay there? Alright, let's find the derivative. So it's radical 2 times, we're using the power rule. Negative 1 half r to the power of negative 3 halves. Exactly, we're subtracting 1. And then final answer, negative radical 2 over 2 r to the power of 3 halves on the bottom. Much easier. No complication. Yeah, you're not wrong. But I don't have faith in the algebra skills to all the kids to do it perfectly right. Radical monkey in the denominator, multiplying with a derivative of 2 over r, nah, it's not going to happen. This is very simple. Okay, if you take, while I erase the board, if you take 30 seconds to a minute and look at all the problems you've done, observe the rewriting we did. Every problem is kind of clever. Saying, oh, if you think about it this way, the problem becomes much easier. Is that clear? Okay. Okay, look, browse through your notes. Yes.
Why doesn't the radical 2 go away?
Sorry?
Why doesn't the radical 2 go away?
That's radical 2 times 1 half, which is not a radical that I can cancel.
No, but because there's no variable.
Sorry?
There's no variable in the radical 2. So when it just equals 0.
Can someone answer the question? They say, look at the board please. Here's an analogy. Okay, I honestly did not know that confusion would arise. What's the slope of 4x? According to you, it's 0.
There is no x in the radical. There's no variable in radical 2.
It's multiplication.
No.
Is that a good analogy? What? Why is that a different problem? It's the same problem. When we are finding, can you see that's a constant times, as I say, it's a multiplication. Don't we just pull out the constant? Okay, we're not doing product rule as in, oh, the slope of 4x is slope of 4 times slope of x, right? That's what you're doing. Alright, now let's go to example number 2, please. Everybody, copy down example number 2. Now looking at that function, is that much more complicated than what we did yesterday? You observe that? Alright, let's do this together. We learned this phrase yesterday. What's another word for that phrase? This derivative. Let me just find the derivative. Stay with me. So what am I writing on the left hand side? F dash of x equals 4. Stop. Let me guide you. What's the slope of cos inverse monkey? Negative 1. Go. Negative 1 over radical 1 minus. Thank you. Will that become sine squared x? Do you understand why? Isn't it sine x squared? Monkey squared. Now stop. I don't want to address a common error because there are enough wrong answers that makes me alarmed. Like, whoa, what just happened? Because I asked the formula, what's the slope of cos inverse monkey? And kids are answering with the letter x. Do you understand why I say emphasize the word monkey? In the other class too, the kids were answering correctly. I said, what's the slope of cos monkey? And the kids correctly said negative sine monkey. And the reason I asked that is this. There's a subtle difference. Because if I say, what's the slope of cos monkey? And you say negative sine x. Trust me, are you not tempted to write x on your paper? It's monkey. So the correct answer is negative 1 over radical 1 minus monkey squared. There was sine squared. Because I heard enough kids say x squared. No, where is x squared coming from? That's not an x. What are you guys doing? Okay, times cos x. Is that clear? Now, what's your friend? That is cute. What's your friend? Yeah, rewriting. Rewriting is my friend. That's my only friend in life. Negative 4 cos x over radical 1 minus sine squared x. Is that clear? Okay, now do I have a point? Let's plug it in. Careful. Follow my lead. Guys, I'm telling you, look at me. There was an email sent to that effect. I'm formally stating it was kind of dedicated to Ben Sophia. If you kind of do your own thing on your homework, I'm not giving you credit. You have to mimic class of notes. Because those are AP standards. I'm not scolding you. I'm just telling you, Ms. Rios and Ms. Basu will tell you exactly what I do, because at the end, we look at the rubric, right? It is exactly what we do in class 1. And I can show you the AP rubric, what the steps they demand. You'll say, oh, so I need a left-hander. Oh my God, I'd never write that. Oh, they say limit there. Oh my God, I don't do any of this stuff. You lose points. Relax, I'm just training you to get that 98%. I don't want you to, 100%. What the hell is 98%? Alright, moving on. So, observe. Now, am I not finding the slope at 5 pi over 4? Observe the notation. And dash of 5 pi over 4. And I'm ready to plug it in. Don't just plug it in there. No, F dash, I'm finding the slope at 5 pi over 4. Okay, let's do this together. Negative 4, cos 5 pi over 4. I'm going to accelerate a little bit. Radical. Relax. The final answer is absurdly easy. Sine squared 5 pi over 4. Now, me, I'm going to do a lot of mental math. Now, look at me. Who remembers? Is the reference angle basically 45 degrees? Now, all of you at this stage, your BC kids, should have memorized this. What's cos of 45 or sine of 45? 1 over radical 2. It's an important skill. Write this down in a box, in your toolbox. You need to know that. Sine of 45 and the cos of 45 are equal. 1 over radical 2. It is smart to know that. It will accelerate your process. Because we can do a lot of the steps in our minds. Now look at me. Which quadrant is 5 pi over 4? Third. And is cosine negative or positive in the third quadrant? Negative. So is that actually negative 4 times negative 1 over radical 2? Over square root 1 minus negative 1 over radical 2 square. Okay, now let's do a bit of mental math. What's 1 over radical 2 square? What is 1 minus 1 over 2? 1 over 2? What's the square root of 1 over 2? Square root, silly boy, not square. What's the square root of 1 over 2? 1 over radical 2. So write it down if you need to. 1 minus 1 over 2, 1 over 2. It becomes 1 over radical 2. Ooh! What do you observe happen? Look at the top and look at the bottom. They cancel. Okay? That 1 over radical 2 and that 1 over radical cancels. So what's your final answer? Positive 4. There's a negative 4 there and there's a negative 1. How easy was that? That entire problem just collapsed into 4. Slow and steady, slow and steady. Again, the square root of 1 over 2 is 1 over radical 2. Repeat. That 1 over radical 2 cancels with that 1 over. Everything just vanishes. Negative 4 times negative 1 is positive. Okay? Alright. Copy down number 3, please. There was a typo in the problem. This is supposed to be just x. Okay, stay with me. Okay, copy down the problem, please. No. Sine of 45 is 1 over radical. So 1 over radical 2 squared, negative square is positive. 1 over radical 2 squared is 1 half. 1 minus 1 half is 1 half. Square root of 1 half is square root of 1, 1. Square root of 2 is radical 2, so 1 over radical. That cancels with the top 1 over radical. Okay, we've been doing math for a while that use this concept. If I have a horizontal tangent, what must be true? Say that loudly. The slope is 0. Does that make sense? If you're writing good notes, please underline that. So slope should be 0. What's another word for slope? Derivative. So f dash should be 0. Is that clear? So should I just find the slope and set it equal to 0? The answer is magically sure. Let's do that together. So f dash of x. I should use the product rule. Is that clear? Look down. I'll walk you through it. So keep the first guy fixed. Take the derivative of the inside, which is negative sine x plus cos x. Is that clear? Plus, keep the second guy fixed. Cos x plus sine x times ex. Everybody okay there? And I should set this guy, be alive with the problem. Yeah, but horizontal tangent. Okay, I said this before, I'll say it again on the homework. In certain problems, I give a tip. So here was a tip, I'm going over the tip again in class. Mr. Ordaz. The tip was this. If you have an EX, and if you observe, do you not have EXs throughout? If you think about it, do you not have EXs throughout? the calculus rule, the convention is you will factor out the EX. For those of you who say, I don't know how to do it, watch. So I'm going to distribute to make it easier on myself. So negative EX sine X, I'm just distributing, look down, distribute. EX cos X plus EX cos X plus EX sine X. And what do you observe happen? And then what algebra can I do? What can I do next step? Thank you. What's EX cos X plus EX cos X? 2EX cos X. So basically I'm factoring out EX. So cos X plus cos X, 2 cos X. EX cos X equal to 0. Now in the first 7 days of school when we were doing a review, I showed you how to do this problem. So what should I just do next step? It says, oh, let's not waste time. Will the 2 just vanish? Divide by 2, 2 vanishes. So I have EX times cos X equal to 0. So what do I do next step? Yes, Ms. Marcus. So what should I do?
Set them both equal to 0.
Thank you, because I have super sharp hearing. Just set both of them to equal to 0. We did a problem like this on day 1, day 2. So EX equal to 0 and cos X equal to 0. Solve them yourself, tell me what to do. Just solve them separately. What form are you in? What form should you go to? So what is the answer to the first part? Thank you. Does not exist. No solution. You can't do log of 0. You need to know that. You're supposed to be in BC. And what are the 2 solutions for cos? Pi over 2 and 3 pi. Is that clear? It looks complicated, but simplifies quite a bit of algebra. Slow and steady, work it up. Slow and steady, work it up. Okay. Being a good teacher, let's do another problem on chain rule. So this was question 1920 yesterday. Okay? We're doing a review problem. Being a good teacher. So copy down the instructions, please. Shh. Okay, stay with me. I went over this yesterday, I'm going over it again. First, I need a... Okay. So what would your left-hand side be? So what should I write on the left-hand side? F, G of X, dash, thank you. Now I need to find the derivative of F of G of X. I need a left-hand side. Is that nothing but the chain rule? So call it the formula for the chain rule. Very good. F dash of G of X times... Okay. Guys, everybody should know it. Yeah, if you want to memorize it, but that's how the chain rule works. Take the derivative of the outside times the derivative of the inside. Is that clear? Let's just go about finding what we need. Should we plug in negative 1/2? So observe the calculus notation. I'm speaking so the board. Now x equals negative 1/2. So I'm now plugging in f dash of g of negative 1/2 times g dash of negative 1/2. Is that clear? Now, you don't need to memorize anything. You can't say, I don't get any punch in the face. Can you just follow instructions? So what does it ask you to find? Look at that expression. What does it ask you to find first? Okay, he's doing this first. Alright, fine. He says, let's do this first. Order does not matter. Or, could we also do g of negative 1/2? That's fine. Alright, I'm just to be perverse, I'm going to do that guy. Okay, let's find g of negative 1/2. So, I'm going to plug it in there. So I'm finding g of negative 1/2, which is sine inverse of negative 1/2. Ooh! Review of inverse trig. Which quadrant am I in? 4? Yeah. Okay. Inverse trig, sine is 1 and 4. Sine is y over r. Who can tell me the correct answer to sine inverse of negative 1/2? Hint, we are in the 4th quadrant. Very good. Negative pi over 6. These are basic skills. Alright. So we know this guy, we know this guy. What do we need to find next? Louder? F dash. Can we find F dash? Find F dash yourself. Look down. Again, you don't need to stare at the board. You don't need to. The problem tells you exactly what you should find first, then next, and then what to do. So what's F dash? 6x plus 2. Now what should we do with the guy we just found? Plug it in here. Is that clear? So we're going to do F dash of, was it what, negative pi over 6?
Yeah.
Okay, negative pi over 6. So 6 times negative pi over 6, look down, plus 2. Simplify, tell me what you get. Negative 5, last 2. Everybody okay? So far, we have done this. I'm showing you what we've done. We have found this. What else? What 2 things need to be done now? Find G dash of x. Look down. Careful. So G dash of x. Ooh, sine inverse. Which is 1 over radical 1 minus x squared. And what should I do with this guy? That it is asking me to do. Plug in negative 1/2. Miss Hanson, very similar to the previous problem. What's negative 1/2 squared? No. What's negative? We're going to plug in negative 1/2. What's negative 1/2 squared? Let me show the word. Slow and steady. What's negative 1/2 squared? 1/4. What's 1 take away 1/4? 3/4. Careful. What's radical of 3/4? Radical 3 over 2. But it's 1 over. So what does it really become? 2 over radical 3. Is that clear? Slow and steady. I'm just walking in. At home you have to do every step. And then what do we do with these 2 results? Multiply. So final answer, negative 5 plus 2 times 2 over radical 3. It looks weird, but that's okay. That'll be the multiple choice. Not too difficult. Yeah, that's it. So guys, chain rule is stupidly easy. Look at the formula and say, okay, I need that, I need that, I need that. Is that clear? And go over finding it. It may look weird, but that's fine. Okay, we're running out of time, so I want to accelerate. We're still doing chain rule, but I want to show you something. Okay, I want to show you something. So copy that down, please. It says use the chain rule to find. Guys, this time make a note of y is a function of x. Okay, x is a variable, a regular variable, and y is a function of x. So we'll apply the chain rule. I'm going to accelerate a little bit. Okay, stay with me. In case you're wondering why does this look weird, it's just like yesterday's function. Yesterday we wrote f squared, don't write. Yesterday we wrote f squared, we are writing y squared. Are they the same? F and y? Okay, don't get f. Okay, I'll do the first one and you just play along. We're applying the chain rule. I'll do the first one, you guys play along. So we're finding the derivative. I'm going to write the answer, see if you play along. Hint, it's just like f. Is that a power? So I'll use the power rule. So 2y times the derivative of the inside. This is applying the chain rule. Yesterday we operated with f's, today we operate with y. Same idea. Okay. Copy it on B, please. Copy it on B. 2. And now keep in mind x is a variable. And what's the slope of 2x? 2 minus 3. What's the slope of y? Y dash. That's how easy it is. It's very basic. It's very easy. Y dash. Okay. I'm going to skip C. Let's go to D. I'm seriously running out of time. Okay, let's do D together. Hint. Chain rule. That's monkey. Is that clear? That's not X. That's a monkey. Okay. Put a dash. So you know you're finding derivatives. Okay, let me walk you through it. Please look down. It'll be faster. What's the slope of cos monkey? Negative sine 3y times. What's the slope of 3y? Very good. 3y dash. Okay. Let's skip E. Let's go to F. Okay, we're doing F. Alright. Which insanely smart fellow tell me how to do F? Louder? Product rule is correct. Product rule. Who said that? Super Sweet Mazu? Yeah, she's right. Product rule. Because I said X is a function. Y is a function. So we use product rule. Everybody okay there? Look down. I'll walk you through it. Keep the first guy fixed. What's the slope of Y? Y dash. Very good. Plus Y. What's the slope of X? Just 1. Slope of X is 1. So it's the letter X. So I'm going to rewrite it. Is it x y dash plus y then? Did everybody pretty much get the hang of what's going on? Okay, let's skip. Let's do H. Last one. Let's do H. Copy on H. Okay, do it with me. We're applying chain rule. Put a dash here. We're applying chain rule. I'll ask you the questions. What's the slope of E monkey? E monkey. Times. Okay, now you're learning something new. Please put a parentheses. You're applying chain rule. I'll walk you through it. What's the slope of X? What's the slope of Y? How easy is that? Just follow along. If you understood this, we're learning the last idea of the day is something called implicit differentiation. Okay? So we'll come back to you very quickly in this videos and this Copy number 8 now. Do you observe in this problem x and y are together on the same side? Has that ever been the case? No, right? Usually y is on the left, x is on the right. So you're learning something new called implicit. Please write this down. It's called implicit differentiation. If you understood the chain rule, you will be fine. Guess who's fine? Megan Fox. My kids in the other class say she's old now. She's probably in her 40s, all wrinkled, and I don't know. They were just joking about it. Megan Fox is no longer hot. She's like, differentiation. Did she interrupt a Megan Fox joke to ask what the math was? Seriously? Seriously, Rani? Okay. Alright, let's do this together. So write down the instruction, find y dash. We're solving for y dash. Your final answers look weird. It's okay. It's okay. Just play along. It's stupidly simple. Okay. I'll ask the question. Look down. You don't need to look at the board. You know how to do it. Okay. What's the slope of 4x squared? 8x. Now careful. I'm going to apply the power rule chain rule. Careful. What's the slope of 6y squared? Initially 12y times y dash. Right? Derivative of the inside. What we just did. I hope you understood that. 12y, then the derivative of the inside, which is y dash. What's the slope of 25? 0. Now what does the question say? Find y dash. I'm going to solve for y dash. So should I get rid of this guy? Should I subtract that guy? So 12y y dash, rewrite, equals negative 8x. Last step. Girls, if you're writing good notes, circle this so you know what we're talking about. I'm solving for y dash. That's what the question says. Solve for y dash. So last step. How easy is that? Yes, your answer has an x and a y, and that's okay. By the way, can we simplify it a little bit? Okay, do it yourselves. And that's how easy the lesson is. That is basically today's lesson. Okay, copy down 9, please. Stupidly simple. We'll do 9 and 10, then we're done for the day. Okay, in case you're wondering how many problems to go. We'll do 9 and 10, then we're done for the day. Okay, copy down 9, please. I'll walk you through it. Okay, Marzu. Okay, let them answer. Alright? Alright, what's the slope of 3x? 3. What's the slope of negative 4y? Negative 4y dash. Is that clear? Okay, nobody speaks. What's going on? Rather, others can speak except Marzu. What should we do on the right hand side? Product! There's a product in there. Okay, I'm helping you. If you're writing good notes, please do this. Let this be your first function, let that be your second function. Is that clear? Okay, let's do this together. Keep the first guy fixed, therefore, times y dash. Very good. Plus, keep the second guy fixed, times 2. Please, rewriting is your friend. Rewriting is your friend. Please, don't simplify immediately. Trust me on this. I've taught this enough. If you start solving, you'll get it wrong. So is that 3 minus 4y dash equals 2xy dash plus 2y? It's nicer to look at. Rewriting is your friend. Now keep the goal in mind. Ariana, pay attention now. Keep the goal in mind. I'm solving for... Okay, now basic algebra. Guys, at this stage becomes an algebra problem. No calculus. No calculus involved for the rest of the lesson. Look at me. I'm solving for y dash. Is it smart? Kind of. Wink, wink. Can I move this to the other side so the y dashes are together? Can I get that guy to the left side? So draw an arrow so you know what's going on. Move this here and move this here. Because I'm solving for y dash. I'm drawing an arrow so you can understand what's going on. So it becomes 3 minus 2y, very good, equals 2xy dash plus 4y dash. Okay, keep the goal in mind. I'm solving for y dash. Which clever fellow will tell me what to do on the right hand side? Very good, factor of the y dash. Please write this notes, factor y dash. Many kids get lost like, what am I doing? No, the goal is to solve for y dash. So factor out the y dash. Relax, we still have 3 minutes. Because I see everything. So I'm going to factor out the y dash. What comes inside? Guys, don't take out the 2. Do not take out the 2. Take out the 2. 2x plus 4. And what do we just do last step? How easy was that? So y dash equals, now move to the left side. 3 minus 2y all over 2x plus 4. That wasn't too bad, right? It was just algebra last 2 steps. Okay, we'll do one more, but a shorter problem. Okay, Okay, slow and steady. Jin, be honest. Aren't you much happier in front?
Yeah.
Seriously. Taurus at the back. Seriously. Come on now. I'm kidding, Taurus. That was a joke. That was totally a gag. It wasn't. Okay, copy down 10, please. Copy down 10. This is not a typo. This is supposed to be 3. Guys, that has a typo. That's a 3. By the way, what are they also giving you? So what do you think we should do in the very last step? Plug it in. It's stupidly easy. Alright? So again, I'm going to walk you through it. Look down. I'm going to walk you through it. It's stupidly simple. I'm going to walk you through it. What's the slope of x squared? 2x. What should we apply in the middle? Product rule. So should I underline negative 3x and y is one variable, right? Keep the first guy fixed, which is negative 3x times y dash. Very good. Plus y times. Very good. Power rule, chain rule. What's the slope of y squared? 2y y dash. Okay. Power rule and then chain rule. What's the slope of 9? 0. What is your friend? Rewriting. Rewrite it to make it cleaner. So 2x minus 3xy dash minus 3y, very good, plus 2y dashes equal to 0. Keep the goal in mind. I'm solving for y dash. So which term will go to the right hand side? 2x and negative 3y. Is that clear? This is an easier problem. So negative 3xy dash, look down, plus 2y dash equals what's on the right hand side? Negative 2x plus 3y. Very, very good. We're almost done. We're almost done. I have 2 y dashes. So what should I do next step? Factor. Factor. We wrote down notes. You need a factor. We're solving for y dash. What comes inside? Negative 3x plus 2y equals. We are done. We're done. We're done. Last step. Divide. We have negative 3x plus 2y. What does the question also ask you to do? Just draw that arrow. Is that easy to do? And we are. Okay, I'm here after school. If you have a question, please ask me. Question, clarity, please do ask me. Thank you. Yes, please. Guys, make sure you're turning in your homework, please. Yeah. Can you tell? Yeah, Google what's the slope of 4? Oh, what? Why that? Yeah, that example. Yeah. No, I know.
And I was like, I cried and then I just probably.